Hello guys, how are you today? So today I'm gonna be talking about the topic 10 metals, or it's a summary, okay, of the topic 10 metals. Now, as I discussed before for the topics 5, okay, these are not actual chapters. They're not chapters that you can find in the book of chapters. You can find it in the book of topics if you want to read the book, or you can find it as the PDF versions on the internet. Sorry, not on the internet, on the SDP. But usually I don't do a summary for topics, but I only did for topics 5 and 10 because they were very long and I felt like I needed to do a summary for them. Okay, so let's not waste more time by talking. Instead, let us just start with the actual explanation. So, topic 10 talks about metals. First of all, what are metals? Metals, they are a class of substances that share the same properties. Okay? Now, what exactly does it mean, a class of substances that shares the same properties? That means metals in general, okay? They have a specific amount of properties or some specific properties. These properties, we'll discuss them in a bit. And if you get an object and you don't know what this object is, or you get an element, you don't know what this element is, and you bring out the general physical properties of metals, and you see that it will abide to every single one of them, then it is what it is going to be classified as a metal. Okay, so let us look at the general physical properties of metals. The general physical properties of metals. We will start with, I don't know if they're all gonna fit, but just like okay, I was trying to scroll down. Anyways, I don't know if they're all gonna fit, but if they don't, I will open it on the next page. The first general physical property of a metal is that they are good conductors of heat and electricity. Okay? Now, the second general physical property of metals is that they are all solids at room temperature except for mercury. So, they are generally solids at room temperature, at RTP means at room temperature, except for one metal, which is mercury. If you want to find mercury, you can find it in the old thermometers, but it's a very poisonous and toxic gas, so do not put yourself in danger to play with it. Okay, so again, a general revision of what we just did. The general physical properties of metals, they are good conductors of heat and electricity. Sorry. And they are also solids at room temperature except for one metal, which is mercury. They also generally all have high melting points. So they also generally have high melting points. This is another point we can put. High melting points. Okay, and then we have high density. They also have high densities. High density, except for one group of metal, which is the alkali metal. Now later on we will discuss about alkaline transition metals. Now be patient because we're still we're at the start of metals, okay? So except for the alkali. Now, another property is that it is ductile. Ductile means it can be drawn into wires. Also, another property is that it is malleable, okay? Malleable. Malleable means that it can be hammered into shapes. So ductile means it can be drawn into wires, it can be made very thin, whereas malleable means it can be hammered into shapes. You can change its shape. Then it also has a silvery luster. Okay, it has a silvery luster means like when you look at it, it has a silvery color or a silvery shine. All of this is true for the silvery luster is true for all metals except for gold, because we know gold is not silver, and copper, because we also know that copper, it is not silver. Okay, I'm gonna move down just a little bit. After silvery luster, we have sonorous. Sonorous. Okay, what does sonorous mean? This is a new term, okay? But sonorous means that it makes a sound. So when you hit it with a hammer, it will make a sound. We know this to be true. And you can test it out if you get like a pot or a pan and you start to hit it. It will make a sound, and like the sound will kind of have an echo. So let's just do a quick recap of what we've discussed. The general physical properties of metals: they are good conductors of heat and electricity. They are solids at room temperature, except for mercury. They have high melting points. They have high densities, except for alkali metals. They are ductile, meaning they can be drawn into a wire. They are malleable, meaning they can be hammered into shapes. And they have a silvery luster, meaning they have a silvery shine, except for gold and copper. And then finally, they are sonorous, which means they can make sound. By the way, another extra information, which it's not that important, but it's nice to know, is that they can be polished. So they can be polished. You can polish the metals. Okay? So now we were discussing what? We were discussing the general physical properties of metals. What about non-metals? What differentiates the metals from the non-metals? Now we are gonna see why actually metals are classified as a group by themselves. Because non-metals, first of all, they are poor conductors of heat and electricity. Okay, so now you will see that everything is gonna oppose what is happening to metals. So non-metals, they are poor conductors of heat and electricity. Okay, now this is kind of something they have in common, except that the non-metals, some of them are solids or gases at room temperature, except for bromine. So non-metals, they are solids or gases at room temperature, except for bromine. Now, what do they mean except for bromine? Except for bromine, it means that it is a liquid. Bromine is a liquid at room temperature. Now we will move on to the discussion of the melting points. They have low melting points, okay? Also, I apologize if my tablet glitches, because this PDF file or this notes file is 195 pages. So it's gonna lag a little bit, so please do not get bothered by it. And my apologies for how much I'm putting in this one file. So, low melting points. So that means non-metals, they are poor conductors of heat and electricity. They are solids or gases at room temperature, except for bromine, which is liquid, and they have low melting points. They are not malleable or ductile, so not malleable. They are also not ductile. So as you can see right now, they are doing the opposite of what metals have as physical properties. Okay? All are soft except diamond with low densities. So again, all are soft, okay, with low densities. They have low densities. They are not sonorous, meaning they don't make sound. Not sonorous. They do not make a sound. And then they have different colors, whereas the metals are only silvery, except for gold and copper. So they have different colors. And they also have dull surfaces. But before we move on, we should know that to everything there is exceptions. So for the metal, as we know that there is, except mercury, okay, that mercury is liquid, whereas more of the metals, they are solids. All of the metals have high densities except for alkali. They all have a silvery luster except for gold and copper. So of course there's going to be exceptions in the non-metals. We have poor conductors of heat and electricity. This is true for all nonmetals except for graphite, because graphite, it is an electrical conductor, and diamond, because diamond, it is a heat conductor. Okay? Here we said that bromine is the exception. Now, we know that all is soft except for diamond. Diamond is probably the only nonmetal that is not soft except for diamond. Okay? By soft, we mean it cannot break easily. Okay? And that is pretty much it. So now, since we are finished with this, let us discuss about the alkali metals. What are alkali metals? First of all, alkali metals, if you look in the periodic table, let me just open it. Okay, so I open the periodic table. Alkali metals, they are always found in the first group, okay? That means group 1, and because they are found in the first group, that means they will lose 1 electron and their charge will be +1, or in other terms, they will have 1 valence electron. Now we will discuss more about them in the notes. Okay, so alkali metals, they can be found in the first group or group 1. First group. Oh my goodness, I keep on clicking on the erase by accident. Okay. The first group in group 1. So alkali metals, they can be found in the first group, which is group 1. Because they are found in the first group, this means what? That they lose 1 electron, their charge becomes +1, or they have 1 valence electron. 1 valence electron, their charge is +1. So they lose 1 electron, okay? And then their charge becomes +1, meaning they have 1 valence electron. Also, one thing you should know about metals is that metals always, they will make positive ions. They will always be cations, okay? They are never anion. Because metals, inside of them, they have a sea of electrons, so they do not need to gain more electrons. Instead, they will lose them. So when they are losing these electrons, they will have positive charges. Okay, this is something very important that applies to all metals. Now, we said that alkali metals, they can be found in the first group, meaning they have 1 valence electron and their charge is +1. They are also relatively soft. So to other metals, they are relatively soft, meaning they can be cut by a knife. They are easily cut by a knife. And as you go down the group in the alkali metals, so as you go down the group. So let me show you what we mean by go down the group. As you go down the group, it means like, okay, we have lithium, you will go down to sodium, you will go down, potassium, you will go down all the way to francium over here. So you start with the first one and you go all the way down. So they said, as you go down the group, okay, what will you notice? You will notice that their reactivity increases, okay? Their melting points will decrease and their density will increase. So as you go down the alkali metal groups, you will notice that their reactivity will increase, their melting points will decrease, and their density will also increase. So reactivity increases, melting point decreases, and density increases. Furthermore, or even more, they have relatively low densities and melting points compared to other metals. So they have relatively low densities and melting points compared to other metals. So that means if you compare it to the alkaline metals, to the transition metals, you will see that their densities are low and their melting points are low compared to the other metals. Now, as we said, they are relatively soft, meaning they can be cut by a knife. But one thing we need to know is that when you cut them with a knife, so when they are cut with a knife, okay, they will have a shiny lustrous surface. So they will have a shiny lustrous surface that quickly tarnishes, that quickly reacts when exposed to air. What you also need to know is that alkalis, not the alkaline, alkalis, they are more reactive than most of the metals. So if you cut them with a knife, their surface, which it will be shiny first of all, but it will quickly tarnish because of a reaction with the air. Okay, so now we will move on from the alkalis and we will talk about the alkaline metals. Okay, what about the alkaline metals? You can find them in the second group or group 2. Okay, let us check it together. So as you can see over here, this is group 2. So you will find them in the second group, and you will notice that they will lose 2 electrons, so their charge will become +2, meaning they have 2 valence electrons. Okay, we'll discuss more about them over here. So they are found in the second group, which is also group 2. They will lose 2 electrons, meaning their charge becomes +2, or they have 2 valence. What's this? Group 2 valence electrons. Okay? Or in another term, their charge is +2. Okay, now there's not too much discussed about the alkaline metals in the notes, but what you need to know is that as you go down the group, okay, you will see that reactivity will increase, melting points will decrease. However, the density is irregular, so you can write density is irregular. So we don't know what actually, what's the constant of change. Will it decrease, increase? No, it's just random. And also some extra information you need to know is that alkalines, they are less reactive than the alkali metal. Now, we finished talking about alkaline metals. We will now talk about transition metals. Okay, so for the transition metals, they don't talk too much about them, but they talk about their properties. Okay? First, they separated their properties into 2 groups. Usually in the AMSs, I remember they would combine them together. But how they did it in the notes is that they separated them into 2 different properties. We have the physical properties and the chemical properties. Okay? So, for the physical properties, transition metals are harder than alkali and alkaline. They are denser than alkali and alkaline, and they also have higher melting and boiling points. So higher melting point and boiling point. Okay, so for transition metals, we have the physical properties. They are harder, denser, and they have higher melting points and boiling points. So now we will move on to the chemical properties. For the chemical properties, okay, we also have 3 properties. The first property is that they form colored compounds. And some example of these colored compounds, we have CuSO4 5H2O. It is gonna be a colored compound which is blue. Okay? Another example, it is FeOH3. It is a transition metal compound that is what? That is rusty brown. Then another one we have, it is K2Cr2O7, and its color is gonna be orange. And then finally, the last color that we have, it is KMnO4, and this color, it is purple. Okay, so we finished with the first chemical property, which is it forms colored compounds. The second chemical property is that they have multiple oxidation states. Now, multiple oxidation states like what, for example? We have, for example, Cu plus, you can have Cu plus or Cu2 plus. Or even you could have Fe2 plus or Fe3 plus. Another example is CO, which is cobalt, CO2 plus or CO3 plus. And then the last example, which is Mn. Mn, it is manganese, so it could be Mn2 plus or Mn4 plus. Okay, and now we move on to the last chemical property of transition metals, is that they have catalytic properties, meaning they act as what? They act as catalysts. Okay? Now, I remember we were talking about the notes of nitrogen and sulfur. And some of the catalyst was vanadium. So wait, vanadium, was it IV or I don't know, vanadium IV oxide. And another one was finely refined iron. Now, if you check on the periodic table, vanadium, which is 23, and iron, which is Fe26, you will see that they are both transition metals. That means they will act as catalysts. Now we finished discussing about the transition metals. Let us move on to something known as the reactivity series. First of all, reactivity series. It sounds like it would mean a series of reaction. Actually, it's kind of like that, but it's more of like which is the most reactive metal and which is the least reactive metal. Okay? Also, another thing I forgot to mention about the transition metals was that transition metals, I will just put it over here. Transition. Oh my goodness, whoops. Transition metals, they are less reactive than groups 1 and 2. So this means they are less reactive than what? They are less reactive than the alkali and the alkaline metals. So back to the reactivity series. The more reactive a metal is, okay, the easier it will form positive ions, and the harder it will be to thermally decompose its compounds. So to decompose its compounds, you need to do it in a chemical way. Okay, so I will just write this note over here. The more reactive a metal is, okay, the easier it forms positive ions. So the more reactive a metal is, the easier it forms positive ions, but the easier it forms positive ions, the harder it is to thermally decompose its compounds. Okay, so the reactivity series, I'm not sure if it will fit over here. I'll try to let it fit over here because it's like just a small arrow pointing up. Okay, this is the arrow pointing up. What does this mean? This means that the metals that are up, they are more reactive. So this is the most reactive. Most reactive metal. And the metals that are down, they are the least reactive metals. Okay, so I will try my best to fit them. I don't know if they're gonna fit, but let's hope for the best. Let's start with the least reactive metal. The least reactive metal, it is gold. After gold comes silver. Okay? After silver comes copper. And then we have hydrogen. This is what? It's like a space. Hydrogen. Hydrogen is not a metal, but it's like a space with what it can react with. Okay, then on top of hydrogen we have lead. Okay, and then on top of lead we have iron. And then on top of iron we have zinc. Okay, and then we have again a space which is carbon. Now, on top of carbon we have aluminium or aluminum. I say it aluminium, sorry. I say it as aluminium, but in the exam they want us to write it as aluminum. And then we have magnesium, and then we have calcium, and then sodium, and then potassium. So they did fit. This is good, but I believe they're gonna be a bit small. So there you go. As you can see, the least reactive metal is gold and the most reactive metal is potassium. Now, what do we mean by these spaces, carbon and hydrogen? So, what is meant by carbon and hydrogen is that anything above them reacts with them. Anything below them does not react. So, for carbon, anything above carbon will react. Hold on, let me choose a different arrow for the hydrogen. Different color, blue. Okay. So anything above the carbon will react with the carbon. However, anything below the carbon will not react with carbon. Same thing for the hydrogen. Anything above the hydrogen will react with it. However, anything below will not react. Alright, so above the carbon we have potassium, sodium, calcium, magnesium, and aluminium. These are the only metals that will react with carbon. Whereas zinc, iron, lead, copper, silver, and hydrogen, they will not react with the carbon. For hydrogen, we have potassium, sodium, calcium, magnesium, aluminium, zinc, iron, and lead that will react with it. Whereas under it, we have copper, silver, and gold that will not react with it. Okay? Now, this is the reactivity series, okay? Now, we will move on to the different types of reactions. We have reactions of what? Reactions of metals with oxygen. So, reactions of metals with oxygen. And oxygen, it is denoted as what? Usually, it is known as O2 gas. Now, usually, a general equation for this is that metal solid plus O2 gas, it is gonna form for us a metal oxide, which is a solid. So metal solid plus O2 gas, it is gonna form for us a metal oxide, which is solid. Now, how do we get the metal oxide? We get it doing the crisscross method. I will do like this. This is a crisscross method. Now we will take some examples and I believe it will become a bit more clearer. So we're gonna take 3 examples. We're gonna take an example from the alkali metals, an example from the alkaline metals, and an example from the transition metals. So first thing, we're gonna take, for example, potassium K. So potassium K, it's a solid, it's a metal. When it reacts with O2 gas, it will form a metal oxide. Now let us see what will be its the metal oxide. We said we will do the crisscross method. So to do the crisscross method, you're gonna take the ion of potassium, so it's K plus, and then the ion of oxygen, which is O2 minus, and then you do the crisscross method, and you will get K2O. So the metal oxide or the product, it is K2O. And this is always going to be a solid. But as you can see over here, it's not balanced. So to balance it, you will put a 2 and a 4 over here. The next example we're going to take, it is Mg from the alkaline metals. So Mg solid. Okay, this is from the alkaline metals. It will react with oxygen O2 gas to produce the metal oxide. So let us see what is the metal oxide. We're going to take the ion of Mg, which is Mg2 plus, okay? It will react with oxygen, which is O2 minus. You do the crisscross method. Because they have the same number, you can cancel it out very simply, and you will get MgO. Okay, so the metal oxide, it is MgO. And it's always a solid. As you can see, it's not balanced. So to balance it, you're going to put A2 over here and A2 over here. Now, finally, we have the transition metal last. We have Fe, okay? Fe, we're going to take Fe3 plus as the ion. Okay, so Fe3 plus is the ion. Fe solid, the metal, will react with O2 gas to form the metal oxide. To get the metal oxide, we're going to do Fe plus O2. Or, so we'll take their ion, so Fe3 plus we said, and O is always O2 minus. You do the crisscross method, you will get Fe2O3. Okay, so the metal compound, it is Fe, or the metal oxide, it is Fe2O3. As you can see, it's not balanced. Sorry, don't forget to put the solid. As you can see, it is not balanced. So put a 2 over here to balance it, a 3 over here to balance it, and a 4 over here to balance it. Now, some side notes that you need to know. Silver and gold, they do not react with oxygen. They don't react with oxygen, O2 gas. Okay, so like keep this in mind. Now we move to a different reaction. This is what? This is a reaction of metals with water. So a reaction of metals with water. Now, a general regular equation of metals with water, it's usually metal plus water. It could be liquid or steam. It could be liquid water or steam water, so water as a gas. It will form a metal hydroxide in addition to H2 gas. Now, another equation that could happen, now this happens for some specific metals, I'll try to get the metals for you. It is metal plus water will give us a metal oxide plus H2 gas. Okay, so I got some information. So look what happens over here. We have sodium, potassium, and calcium. They usually react with what? With water, but they react with cold water to produce what? To produce the metal hydroxide and H2 gas. Whereas here we have the aluminium, however you want to write it, but just like write it like this. This is how they want you to write it in the exam. And zinc. They will react with water, especially hot water or steam, to form a metal oxide plus H2 gas. Now there is one exception, which is magnesium, Mg. It will do metal plus water, but this water, it is hot water to form metal hydroxide plus H2 gas. So again, over here we only have magnesium. Okay, so here this water is cold water, this water is hot water, and this water is hot water. Okay, so sodium, potassium, and calcium, they will react with cold water to produce a metal hydroxide and H2 gas. Whereas aluminum and zinc, they will react with water, with hot water, to produce a metal oxide and H2 gas. Whereas magnesium, it will react with hot water to produce metal hydroxide and H2 gas. So let's just take some examples. We have sodium, Na, will react with water, H2O, so Na is solid, H2O, we said cold water, so it's liquid, to produce sodium hydroxide, so NaOH in addition to H2 gas. So it's not balanced. To balance it, you're going to put A2 over here, A2 over here, and A2 over here. Now, another example we will take from the aluminum and zinc, or the zinc, aluminum, whatever. We have zinc Zn solid will react with H2O gas because it reacts with hot water to produce zinc oxide plus H2 gas. Here there is no need to balance, it's already balanced. Okay, and now for magnesium. Magnesium, Mg, it will react, sorry, it's a solid. It will react with H2O, but it's hot, but it's gonna stay as a liquid. So magnesium solid will react with H2O liquid to form what? To form MgOH, 2 in addition to what? Hydrogen gas. Okay, so we can make it a basic rule that if it's reacting with water that is liquid, it will form the metal hydroxide. However, if it's reacting with water that is gas, it will form a metal oxide. Okay, so let's balance this one down. I think we only need to put a 2 over here, and that's it. That's pretty much it. So that's it actually for the reaction of metals with water. Okay, so now we will move on to something new. Okay, let me just choose a color. Let's do this color, which is reactions of metal with acid. Reactions. Oh my goodness, whoops. Reactions of metal with acid. So, reactions of metal with acid. We have a general formula, which is metal plus acid will form a metal salt, okay, in addition to H2 gas. Now, here you need to remember some metals do not react, whereas some metals do. So the metals that react, okay, they are potassium K, sodium Na, calcium Ca, magnesium Mg, aluminum Al, zinc Zn, and iron Fe. Whereas the metals that do not react, okay, they are Pb, Cu, Ag, and Au. Alright, now let's just take an example. For example, if we took Na in addition to HCl, Na it is a solid, HCl it is aqueous. They are always aqueous, by the way. The acids, they are always aqueous. They will form a metal salt in addition to what? In addition to H2 gas. Now the metal salt, what's gonna happen is that we know Na, its ion is Na+, whereas HCl, its ion is what? Is H+, and Cl-. So what's gonna happen is that the Na+ is gonna take the Cl-, and it will become NaCl. Okay, so now the metal salt is NaCl, and we got hydrogen gas. As you can see, it's not balanced. So to balance it, we're gonna put A2 over here, A2 over here. Okay, it's glitching a little bit, and A2 over here. So that is pretty much it. And the NaCl, I believe it's gonna be aqueous, either aqueous or solid, but for now I think to keep it as aqueous. Okay, so that's pretty much it for this one. Now we will move on to the reactions intensity. This is a very important part, okay? Reactions intensity. We're gonna be discussing, I will just say the metals right now: potassium, sodium, calcium, magnesium, aluminum, zinc, iron, and that's all. These are the only metals we're gonna be talking about in the reactions intensity. So we first start with K, which is potassium. Okay? When potassium reacts with cold water, okay, it has a very violent reaction, okay? It has a very violent reaction in cold water, and it forms H2 gas which burns with a lilac flame. So which burns with a lilac flame. So again, potassium, when it reacts with cold water, it has a very violent reaction. It forms H2 gas, which burns with a lilac flame. However, when it is reacting with an acid, with a dilute acid, okay, it has a very, very violent reaction. Okay, so it's glitching a little bit, so bear with me 1 second. A very violent reaction that forms hydrogen. Okay? So it's a very violent reaction that will form hydrogen, but it's very violent and dangerous that it should not be tried in the lab. So violent and dangerous, never try in a lab. Never try in a lab. Probably an explosion happened because, as you know, hydrogen, it will explode. It makes a popping sound because it's exploding. So again, potassium, okay, when it reacts with very violent reaction, it will form H2 gas, which burns with a lilac flame, whereas with a dilute acid, it will have a very violent reaction which forms hydrogen, but it's dangerous and should never be tried in a lab. We move on to sodium, Na. This is sodium. Okay, it's gonna glitch a bit because we're like over 200 pages now. So when it reacts with cold water, okay, the reaction is a very violent reaction, not very violent, actually violent reaction, less violent than potassium. Violent reaction, okay, and which forms hydrogen, forming hydrogen, okay. However, when it reacts with a dilute acid, okay, the reaction is very violent as well. It will also produce hydrogen, but it's very violent and dangerous, and it should never be tried in a lab. So never try in lab. Okay, we move on to the next metal, which is calcium, Ca. Now I believe my tablet will glitch a little bit because of the amount of papers we have. Again, do not be bothered by it. I apologize for how much papers I have compacted in here. So when calcium reacts with cold water, it reacts well. So it's not dangerous, it's not violent, it reacts well to form CaOH, calcium hydroxide, which will turn milky white. Okay, and that's it for the cold water. When it reacts with an acid, a dilute acid, okay, it is a very vigorous reaction. So it's not as violent, but it's still very very dangerous, very vigorous reaction. Okay, we move on to the next metal, which we have it to be magnesium, Mg. Mg, magnesium. When it will react with cold water, okay, it will have a reaction, but it is a very slow reaction. Very slow, like my tablet, very slow reaction. However, if you heat up the water and you change it into steam, it will react readily. So steam will burn it readily. However, when it is reacting with a dilute acid, okay, with a dilute acid, it is a vigorous reaction, not a very vigorous, but a vigorous reaction. Okay, that will form gas bubbles. Gas bubbles will form, and magnesium will disappear. Mg disappears. disappears, and a colorless solution forms. And colorless solution forms. These gas bubbles, they are usually hydrogen gas, because when you react a metal with an acid, a dilute acid, it will form a hydrogen gas. Now we move on to the next metal, which is aluminum, or aluminium, Al. Aluminum, okay. It will react with steam, not with cold water, with steam, because as we said, it will react with water gas, okay. When it will react with steam, it will provide an oxide layer. So it provides an oxide layer. So it will react with the steam to produce an oxide layer for itself. Now, with acid, with dilute acid, okay, especially cold acid, so the aluminum will react with cold acid, okay. It is a slow reaction, okay. Again, bubbles form, and then aluminium will disappear and a colorless solution forms. Aluminium disappears to a colorless solution, So for aluminum, with a dilute acid, especially cold acid, this is AC, a slow reaction will happen, bubbles will form, and aluminum will disappear to a colorless solution. Now we move on to the last two metals. The last two metals, they are zinc and iron. So zinc, zinc. It will react with steam, which is gas. Not gas, it is the steam, which is gas water. It will react with steam, okay, and to form zinc oxide. Zinc oxide is produced, okay, and it is yellow when it is hot and white when it is cooled. So yellow when hot, and white when cooled, okay. However, to react with an acid, a dilute acid, okay, bubbles will form, okay. Again, it's like the aluminum and magnesium. So bubbles will form, zinc disappears, and a colorless solution forms. Now finally we reach the last metal, which is iron. Let me choose a color. Here we go. Fe, iron. Okay. Iron, okay, it will react with hot steam or hot water. So let's just write steam, okay. I believe it will form an iron oxide, okay. Now when it reacts with a dilute acid, iron disappears, just like zinc and aluminum and magnesium. Fe disappears, and a pale green, oh my goodness, and a pale green solution forms. Okay, now finally we finished with these. This is probably like one of the longest parts of this topic. So now we will be discussing the extraction of metals. How do we extract metals and how do we make them pure? Okay, extraction of metals means to get the pure metals. So the first thing we have, it is reactive metals. For the very reactive metals, we go to something called electrolysis. We studied this in chapter 4, so if you want to go back to chapter 4 to revise it. Chapter 4, like the book chapter 4, not topics 4. Okay, so the metals that are reactive, we have potassium K, sodium Na, calcium Ca, and magnesium Mg. These 4 reactive metals, we will do an electrolysis electrolysis of molten chloride. Oh my goodness, wait. Of a molten chloride. Okay? So we will have KCl, NaCl, CaCl2, and then MgCl2. These are the molten chlorides that we will have. We will do an electrolysis, and pay attention, it's molten, not aqueous chloride. Because if we were to do it in the aqueous chloride, we will get hydrogen gas and not the metal we want. So to get the metal, we need to do the electrolysis of molten chloride. So it's KCl, NaCl, CaCl2, and MgCl2. Now for aluminum or aluminium, you all know what's this? Aluminum. Okay, when it reacts with aluminum, not when it reacts, when the metal we want to extract is aluminum, we are gonna do electrolysis of molten oxide. Okay? Now, aluminum is by itself. Then we have zinc, Zn. Let me just put their element forms. So zinc, Zn, iron, Fe, tin it is, let me find it 1 second. Tin, it is Sn is tin. Lead, it is Pb. And copper, it is Cu. Let me just double check. Cu. Yeah, copper is Cu. So zinc, Fe. So zinc, iron, tin, lead, and copper. Zn, Fe, Sn, Pb, and Cu. These 5 metals. To get their pure form, we do the reduction of oxides. Okay? So we have a reduction of their oxides, or like the ores. Their oxides are usually ores, and we usually heat them with carbon. Now, after we finish silver and gold, we're going to be talking about the blast furnace, which is the process of extracting pure iron. Okay, so we're finished with this one. We move on to silver and gold. Silver is Ag, gold is Au. Okay, they are already pure, so there is no need to extract them, because when you find them, they are gonna be already pure because they are the least reactive metals. That's why, by the way, also as jewelry, we have silver and gold jewelry, because they are the least reactive, so they will not harm the human skin. Okay? So now we reached what? We reached the blast furnace. I will choose a nice color now. The blast furnace. In the blast furnace, what do? We extract pig or cast iron. Pig or cast iron means what? It means pure iron. Okay? So, the blast furnace, it has 3 main steps, 3 main parts. I'm gonna start with the first part over here, which we will call it step 1. So step number 1 is that we need to take our pure raw materials. So the first step is to take the pure raw materials. We usually need 3 main raw materials. They are usually the iron ore, or like most of the time it is hematite, okay, which is either Fe2O3 or Fe3O4. So iron ore or hematite, it's either Fe2O3 or Fe3O2. This is the first raw material. The second one is coke, which is carbon solid. And then the third one, finally, it is limestone. Limestone, it is CaCO3. Okay, after bringing our raw materials, which is step 1, we'll move on to step number 2. Step number 2 involves the action process, what happens in the blast furnace. The first thing that happens is that hot air, okay, is blasted up the furnace. Okay? after hot air is blasted up the furnace in order to react with our raw materials, we will have what? We will have that the combustion of coke will happen. So coke is combusted. So this is our first reaction. Our first reaction is that coke is combusted. Our second reaction is that iron ore is reduced. Okay, so first reaction, coke is combusted. Second reaction, iron ore is reduced. And now for step number 3, I think I can put it over here, step 3. Okay, we have the formation of slag. Formation of slag. Slag, it is what? Okay, formation of slag is our third reaction. Slag, it is what? It is when the limestone CaCO3 solid will break down into what? Into CaO solid in addition to CO2 gas. Okay, now what happens is that the CaO solid, it will react with SiO2, which is also a solid, to form slag, which is CaSiO3, and slag is a liquid. Okay, so again, what is the process of the blast furnace, which will give us pig or cast iron, which is pure iron? The first step is iron ore. Okay, it is hematite, which is either Fe2O3 or Fe3O4. Then we have coke, which is carbon solid, and then limestone, which is CaCO3. These are the raw materials, which is step 1. Step 2 is the introduction of hot air being blasted up the furnace to react with the raw materials. So when the hot air will react with the raw materials, coke is going to be combusted and iron ore is going to be reduced. And the third step, step 3, which is one of the most important steps, it is the formation of slag. Slag will form. What is slag? Slag is when the limestone will react with, will decompose to form calcium oxide and carbon dioxide gas, and then the calcium oxide will react with SiO2 to form CaSiO3, which is a liquid, and it is slag. Now, what you will notice if you looked at all of the equations for the coke combustion, iron ore being reduced, the slag formation, you will notice that carbon is our major waste. Okay, so carbon is our major waste in the extraction of pure iron. Now that we are talking about pure iron, which is cast or pig iron, we are going to discuss its properties. So properties of cast, aka pig iron. Okay, first of all, it is hard. It is hard but brittle. Hard but brittle means that it will break easily when subjected to pressure, but it will not break by cutting it by a knife. So if you pressure it, if you put too much pressure on it, it will break, but it will not break if you cut it with a knife. And then second, it corrodes easily, means it will react with oxygen in the presence of water to form an oxide, iron oxide, so it will corrode easily. Okay? Now after this, we are going to be discussing corrosion and rusting. Okay, but before we will discuss the uses of cast or pig iron. Uses of cast or pig iron. Okay? So it is first of all used in large objects. Okay? These objects, for example, they're bridges, buildings, ships, etc. But it's also used in pots and pans. So that's pretty much it for the cast and pig iron. Now we will move on to something very important and very nice, which is corrosion. Okay? What is corrosion? Corrosion is when a metal will react with oxygen in the presence of water to produce a layer of oxide. So, when a metal reacts with oxygen in the presence of water to produce a layer of oxide. For iron especially, corrosion is not a good thing. So that's why we have some ways to prevent the rust, and rusting is the corrosion of iron. So before we move on to that, corrosion, okay, it is a redox reaction, okay, and also what we need to know is that corrosion of iron, it is known as rusting. And as we said, especially for iron, corrosion is not a good thing. So that is why we had to discover ways to prevent the rusting of iron. How to prevent rust? Okay, how to prevent rust? We have a few methods to prevent rust. The first method, it is known as the barrier methods, and these are like 3 methods that come from the barrier methods. The first one is to paint. So painting, you can have more information on this in the notes. Then the second one is oiling or greasing, okay? Greasing, so you put oil on the iron, like your iron things, because of their rusting, so they will move easier. And then finally is to coat it with plastic coating, with plastic. Okay, so the barrier methods, we have 3 main methods, which are painting, oiling or greasing, and coating with plastic. So now, this is a new page, yeah? So now we will move on to 3 more different types of plating, or how to prevent rust. The first way is known as, oh my goodness, sorry. It is known as electroplating. Okay? Now, usually, there are some keywords we need to follow. So whenever you see electroplating, you have to look for the keyword coating. The second one is galvanizing. Okay? Galvanizing is the process of plating the metal with zinc. Okay, so what we are gonna say the keyword for this, it is zinc plating. Okay, now finally we have sacrificial protection. Okay, now sacrificial protection is what? When a more reactive iron, not a more, oh my goodness, my bad, a more reactive metal than iron will coat it, will coat the iron, will coat it. So what's happening basically is the metal that's more reactive, it will form the oxide layer and it will protect the iron and prevent it from rusting. Okay? Okay, so now we move on to what? This is unrelated to what's up, but it is the uses of copper. Why do we use copper? We use copper in electrical wires, okay? In electrical wires. We use them because they are ductile and they are electrical conductors. So ductile and electrical conductors. Okay? Then we also use it in alloys. Okay? Because they are hard and they resist corrosion. Hard and resist corrosion. And then we also use it in cooking utensils, steam boilers, and water pipes. Water pipes. Why? Because they are good heat conductors and they also resist corrosion. So they are heat conductors and they resist corrosion. So these are just some uses of copper. Now we will move on to the definition of alloys. What are alloys? First of all, let us choose a color. I'm gonna go with green. Okay, so alloy. Alloy. An alloy, it is a solid solution. A solid solution is something new, but no, you've heard of it before, an alloy. It's a solid solution. Solution means a mixture of metal with other metals or non-metals. So an alloy, it's a solid solution of metal, so like a mixture of metals with other nonmetals or other metals. Okay, so there are some key terms to know whether this substance is an alloy or not. Okay, so key terms. Usually, what happens in the alloys, particles are, like the atoms are replaced. So some of the atoms of the metal are replaced. So some atoms are replaced, not all. Okay, and then particles or atoms fill in gaps in metal. So we're just gonna write that particles, like metal, other metals, other non-metals, they will fill in gaps of the metal. So now, why do we use alloys actually? A very important question. We use alloys as they have properties or more properties that may be beneficial. For example, steel, it is not a metal, it is an alloy. It is a mixture of metals and non-metals and whatever. So let us see some of the properties of steel that make it more beneficial to use or better to use than other metals. So properties of steel. Okay, first one is that it is less brittle than iron. So less brittle than iron. This is a good property. Then another is that it is more resistant to corrosion than iron, which is also something very, very beneficial. And where do we use steel? Okay, so actually we have three types of steel. We have mild steel, we have hard steel, and then we have stainless steel. Now I'm not gonna write where we use them. I'm just gonna say that for mild steel we use it in car bodies and in machines. Hard steel we use it in cutting tools, razors, blades, whatever. And then stainless steel, which is a very famous steel. I believe it's used in cutlery, surgical equipment, chemical plants, and whatever. Stainless steel so that it will not rust and infect, for example, in the surgical equipment, it will not infect the human, or in cutlery it will not affect us when we're eating, or chemical plants, it will not affect them when they are working. Okay, so now we will move on to the electroplating process. How do we protect iron or even other metals? Let us write first of all electroplating, and let us draw a diagram and explain in this diagram. First of all, I will draw it like this. Okay, this is the container, first of all, and this is what it looks like here. And then like this is our battery, and then we have an object over here and an object over here, and then we have a solution. Okay, so let us discuss together. The negative side, or the negative electrode, this is always what the cation. Okay, so I'm gonna write over here cation. The positive side, or the positive electrode, this is the anion. Okay, this we know it very well. So at the anode, or let us write over here anode, and over here the cathode. Okay, at the anode, oxidation occurs. That means a loss of electrons will happen. At the cathode, reduction will happen, so a gain of electrons will happen. Okay, usually the solution over here, we call it the electrolyte. Okay, it is an aqueous solution of the metal on the anode. So electrolyte is an aqueous solution of metal on the anode. Now, pay attention, this is important. At the cathode, or the cation, we place the object to be plated. Okay? So for example, if you want to plate a spoon or a necklace, you will place it at the cathode. Whereas at the anode, you will place the object to plate with. So for example, if you are plating with silver, you will place silver on the anode. Okay, so this is just like a general diagram to help you understand. Again, I will summarize what happened. We will have, first of all, a solution. This solution is the electrolyte. It's an aqueous solution of the metal on the anode. At the anode, we will place the object to plate with. At the cathode, we will place what? We will place the object to be plated, if it's a spoon, a necklace, or whatever. Now we have some details for the electroplating we need to follow. Okay, the first detail is a clean surface of object. Clean surface of object. So the object that we need to plate it, it needs to be clean. There should not be any impurities on it. And also we need to rotate the object from time to time so that the plating is even. So rotate object from time to time. Okay, and then finally dip the object deep in the electrolyte. It should not be up because we do not want it to react with the oxygen. So we are gonna dip the object deep in electrolyte. Okay, now we will move on to the extraction of aluminum. This is, I believe, the last thing we're going to be talking about. Okay, so I will open a new page. And the title is Extraction of Aluminum. Oops, my bad. Aluminum. Okay, so what we need to know, or what we know from before, is that aluminum is a very reactive, but not like way too much, but it's still a very reactive metal. It will react with oxygen to form a layer that coats itself. So aluminum will protect itself. And this layer is called bauxite. Or like this compound is called bauxite. So aluminum, what we need to know, is a reactive metal. Okay? Reactive metal. When it reacts with oxygen, okay, it will layer itself, it will coat itself with an oxide. Okay, so this oxide, it's called bauxite. Okay, bauxite, usually it is a mixture of Al2O3 in addition to Fe2O3. Now bauxite, this is what? This is the ore that we will be extracting aluminium from. The ore from which aluminium, Al, is extracted. Okay, so now for the steps, we have like 3 major steps over here. I will divide them into step 1, step 2, and step 3. So step 1, first of all, we should know that bauxite has a very, very high melting point. So we will add cryolite. Okay, cryolite, what does it do? It decreases the melting point, or lowers, we can say, lowers the melting point of bauxite. Okay, so first we're gonna add cryolite, which will lower the melting point of bauxite, and then we will treat the ore with NaOH, or sodium hydroxide. Now step 2, okay, what happens? In the NaOH, we have that Al2O3 will dissolve. It will dissolve in the NaOH, whereas Fe2O3 will not dissolve, and instead to remove it, we will filter it. So it is filtered. Okay, so the Al2O3 will dissolve in the NaOH, and the Fe2O3 we will filter it. Okay, now finally, step 3. What's gonna happen is that we are gonna electrolyze the solution. So we are gonna do electrolysis. Okay, so of course we are gonna use for our electrodes graphite, because graphite, it is inert and it will not react. That means that it's an electrical conductor. But now let us go to the anode and the cathode. What will happen in the anode of the electrolysis of aluminum and the cathode? So remember, we will dissolve in the NaOH the Al2O3. So what will happen? At the anode, the anion is gonna go, which is 6O2 minus. It is a liquid, okay? And it's gonna form what? It is gonna lose electrons, because anode will undergo oxidation, which is the loss of electrons, to form 3O2 gas. This is O. 3O2 gas in addition to 12E minus. Okay, however, for the cathode, we will have the cation that will go, which is the aluminium. So the reaction is for aluminium 3 plus, which is a liquid. It will gain electrons, because in the cathode it will undergo reduction to gain electrons, and it will form 4 aluminium, which is liquid. And just like that, we got what? We got pure aluminum. Now, because what's happening, we are forming oxygen over here. This is the oxygen gas. The oxygen will react with graphite. So O2 will react with graphite electrodes, with graphite electrodes. Okay? And that is why we must frequently change them. So we must frequently change them. Okay, so now we just need to know what are the requirements for the extraction of aluminium. Requirements: we need electricity, first of all. Then we need a lot of power and money. A lot of power and money. By power, I mean like the power for the electricity. We need a large cooling supply of water. Cooling supply of water. We also need raw materials. We need also a good transport system. Good transport system. And we need water gases purification. Water gases purification. So that is it for the requirements. So now we finally reached probably the end of this explanation. Uses of aluminum. Okay, we use it in cooking utensils. Why do we use it? We use it because it resists corrosion, it has a low density, and it's a good heat conductor. So cooking utensils and food containers. Okay, they resist corrosion. Okay, they are low density. I think my tablet's gonna explode by now. Low density, and they are heat conductors. Okay, then we also use it for making airplanes. Why do we use them for making airplanes? Why do we use aluminum for making airplanes? Because it is low density, and they are high strength. They have a high strength. Now, finally, the last use of aluminium is for a steel-centered. Oh my goodness! Whoops! A steel-centered aluminum Al cable. Okay, basically what is this? We have steel at the center and aluminum on the outsides. We will use steel because it expands. Okay, it's also it expands, but like it expands less than copper. Whoops. Okay, and it has a high melting point. So we use steel because it expands less than copper and it has a high melting point. And then we have aluminum, which is an electrical conductor. Oh my goodness, conductor. I think by now my tablet's gonna explode. It's an electrical conductor plus low density. Now I just want to add something very important. Why it is important to recycle aluminum. So recycle aluminum, because when you recycle aluminum, it requires, or it needs around 5% of the energy actually needed to extract it. 5% of energy needed to extract it. So that's it for this video. Thank you guys for watching. I hope you enjoyed. I also apologize for my tablet being very glitchy and it's gonna explode at some point. Hopefully not. So have a great day and I hope you understood.